Hello, welcome back. This is Calculus by Dr. Oz. Today we're going to find the area of a specific region bounded by the graphs of four equations. One is y equals negative x cubed plus 2. The second one is y equals x minus 3. And you have two vertical lines, x equals negative 1 and x equals 1. So it means like your region is sort of like surrounded by these graphs. So first part of the problem, we should have our TI-84 ready to see what the region looks like. And then we're going to use the integral concept to find or evaluate the value of the area of the region. Okay, so let me just give you like a quick hint right now, because now I have the region plotted for you, but in the video, please do it by yourself because I'll refer back to this. So you have the blue curve and the purple curve, so cubic and in fact a linear part, and you have all vertical lines, two of them, and then you see the green region over there. So we're going to try to find the area of this region in the video. Have your TI-84 ready. Let's get started. All right. Please have your TI-84 and then start plotting y equals negative x cubed plus 2 and y equals x minus 3. And you can start putting your x min to be negative 2, x max to be 2, to see what the shaded, what the area, in fact, surrounded by these graphs look like. And you can pause the video anytime and then you just work through with your calculator. And I'm going to show you what I got here. That as you see that you have the blue graph, which is representing the graph of negative x cubed plus 2. And you have the purple graph, which is the linear, the line, representing y equals x minus 3. And you have x equals 1 and x equals, this is 1 and this is negative 1. And these are the vertical lines. These are not points, by the way. These are vertical lines. So going back to the description here, so you are talking about here the vertical lines and a line with slope 1. And you have the curve, the cubic. Okay. So once you put all together, on the left, the region is bounded by x equals negative 1. Okay, so right here, x equals negative 1. At the top, the region is bounded by the blue curve. On the right, x equals 1 vertical line. And in the bottom, you have the purple graph, which is the graph of the line. So we did similar calculations back in Calc 1 to find the area between the curve and the x-axis. But this time we have the area between the top curve and the bottom curve. So what we're going to use here is the formula that has the top function, so the integral of the top function, which is minus x cubed plus 2, okay, minus the integral of the bottom function, okay, which is x minus 3. And since this region is stuck in between negative 1 and 1 for x's, so I am going to look at the definite integral from negative 1 to 1, and then I'm going to integrate this for dx. All right, so all I'm going to do is to integrate this, and this is, again, the area of the green region here. Okay, so this is the area of the green region here. The top minus the bottom integrated from the x limit, minus 1 and 1. So here we go. Let's simplify this. Okay, minus 1 to 1, negative x cubed plus 2 minus x plus 3 dx. And that is equal to negative x cubed minus x plus 5. Okay, dx. And let's use the power rule for integration to find the antiderivative here. So negative x to the fourth divided by 4 minus x squared over 2 plus 5x. And we're using the fundamental theorem of calculus to evaluate the definite integral with lower limit negative 1 and upper limit 1. Okay. So what we're going to do here is just to plug in the upper limit first, minus 1 over 4 minus 1/2 plus 5. And the lower limit plugged in, well, minus 1 to the fourth. Minus 1 to the fourth is already plus 1. Okay, so I just put plus 1 over there. So, but you still have the minus sign because of the x to the fourth over 4. You have the minus sign in front of that. Minus 1 squared over 2. This is 1/2. And 5 times minus 1 is minus 5. Okay. So please go ahead and simplify this. Well, to start with, minus 1 over 4 and minus 1 over 4, and there's the minus sign here, so we subtract two same numbers, 0. And same thing here, minus 1/2, minus 1/2. So they they're canceled out, right? So this is 5 plus 5, and that is equal to 10. I can go ahead and then say like this area is exactly equal to 10 here. Okay. This was a relatively easier question to start with because these curves, like the blue and purple, they intersect each other, and what I'm trying to say is like they intersect each other right here, but that intersection is not included in the region here. So if that was included in the region, we were supposed to find that intersection of two curves, okay? But in the future videos, you will see that we have examples of that sort taken care of, okay? All right, this takes care of everything in this problem, but make sure you have your TI-84s with you before you start working through the finding area problems, okay? Finding the area of regions, areas of regions problems. So make sure that you have you can sort of like graph the whole region first, then you can decide what kind of integral you should work with at the end. All right, so this is already a long video. I'm gonna stop right here. Thanks for watching. Please send your comments or suggestions to my way. I'll see you in another video. Bye.